Hey boys and girls, Mr. D here. By the time you are done watching this video, you should be a master at factoring out polynomials by using their greatest common factors. Okay, so let's jump right in here and take a look. Here's the first example. Copy it down. Example 1, factor the polynomial. Okay, so in order to do this, slide this up here, you could get a look at our guidelines here. So the first thing we want to do is we want to factor each term by listing the factors. Okay. In order to factor, what we'll do is we'll do the coefficient first, then expand out the variable. So let's take a look at 8x cubed. So we factor out 8. Factors 8 are 1 and 8, and then 2 and 4. Again, some of us confuse factors and multiples. There are few factors, many multiples. Factors are what make up the number. All right, then let's just expand out the variables, right? When in doubt, we expand it out. So if we take a look at our variables, just swap colors here. I got x cubed, so really we'll just say x, x, and x. Okay. So there's 8x cubed factored out. Let's take a look at our next term, 12x squared. So factor to 12, we got 1 and 12. All right, 2 and 6. And 3 and 4. And then if we want to take a look at our variables, we got x squared, so that's x and x. Okay, so there's our 12x squared. We got our factors of it, okay? And 10x. Work with the 10 first. I always like to do the coefficients first, so 1 and 10. And then 2 and 5. And then we just have our one variable, x. Okay, so if we want to look at what they have in common, the greatest common factor of these three terms, well, we see here we have a 2 here, 2 here, and 2 here, and there's nothing greater than any of those. So we have the 2, 2, and the 2. And over here, each of these, they share an x. They all have one x in common. So if you think about the factors here, what we do is then we pull that greatest common factor out of each term. So we're left with this, right? So our greatest common factor is 2x. So we pull 2x out of here. And if you think about what remains, 2x, we pull out 2x, and what remains is you have 2x's here. And we have a multiple of 4 that would remain to get us back to 8. Right? 2 times 4 would get us to 8. Here, if we pull out 2, if we factor out a 2, if we divide 12 by 2, then we have a 6 that remains, and there's 1x here. So 6x remains when we factor out 2x out of here again. So think about dividing the coefficient out. So again, if we said, write it down here, so GCF, these three terms, is simply 2x. So think about dividing each of these numbers by 2. So 8 divided by 2, if you're pulling the 2 out, leaves us with 4. 12 divided by 2 leaves us with 6. 10 divided by 2 leaves us with 5. So that's what remains in each of the terms after we factor out the 2x. As far as the variable component goes, again, if you look here, if we pull out 1x, there's 2 remaining in this 8x cubed term. And here they are right here, x squared. Right? If we factor out 1x, we have 1x remaining in this term. Right? So we have 6x. If we factor out 1x, there's no x's remaining in this last term. So these numbers here that I'm going to highlight in the green, this is sort of what remains from our original term after we factor out the 2x. Okay, and again, you can check it, because if you multiply through, it should get you back to the original term. 2x times 4x squared is 8x cubed, etc. So what we want to do from here now, and I know some of you are already wondering what's going on here, but let's take it a step further. We're going to do, this is officially factoring it out. I like to call it, another way to think of it is reverse distributive property. Okay, since each of these terms have a 2x in common, we can pull it way out to the front here. Okay, and then what remains what remains then is these non-factor terms of 4x squared plus 6x plus 5. Okay? And we can check our answer if we did distributive property here. We should end up with where we started, 2x times 4x squared. Well, 2 times 4 is 8. X times x squared, well, that's going to give us x cubed. Okay, 2x times 6x gives us 12 x squared. 2x times 5, well, that gives us 10x. Okay. So you can see we end up back with exactly what we started with. So this right here would be our factored answer. Well, let's try and do it a little better. All right, so here's our factored answer. All right, let's take a look at another example here. Okay, so 6n to the fourth plus 9n cubed plus 12n squared. Okay, again, if we slide here, here's our rules again. Should these copied down from the previous page. Let's start factoring out each term. So 1 and 6, 2 and 3. Right. Then we have 4 n's. Right. 1, 2, 3, 4. Okay. Since I'm still working, so here we got 9 is 1, 9, and 3. We got 3 n's there. So n and n. Alright, and 12n squared. We did 12 before, it's 1 and 12, 2 and 6, and 3 and 4. I got room there. Okay, so, and then we have 2 n's. And if we look, our greatest common factor that they all have in common, let's see, 3, 3, 3, looks like. Alright, so there's a 3, 3, 3, and they each have a minimum of 2 n's, or they each share 2 n's. Alright? So if we think about that, we're going to, so our greatest common factor, I'd pause the video and you tell me, I want you to write down what you see as the greatest common factor right now. Pause the video and you write it down. Alright, so you should have written down here 3n squared. Okay? Now, take a second again. I'd like you to pause the video and I want you to try and pull out a 3n squared out of each term. Just like we did right here in this step. Right in that step. Pull that out in this step here. I want you to do that for here. Rewrite these 3 terms, pulling it out, see what you get. And unpause the video when you think you got something. Alright, so here's what you should have. Alright, pull out the 3n squared, and think about 6 divided by 3 is 2. Alright, so there's 4 n's up here, and we're pulling 2 of them out. We have 2 remaining. Okay, go to the next term. Again, 9 divided by 3, right here, leaves us with 3. There were 3 n's. We're pulling out 2 of them, so there's 1 remaining. The last term, 12 divided by 3 is 4. There's 2 n's here. We're pulling out both of them, so there's no n's left here with the term. Okay. And if you take it a step further, pull this 3n squared out to the front since they each have it in common. And then you just rewrite the other terms within the parentheses. And again, if you did the distributive property, you would find that you end up with the exact same thing. 3n squared times 2n squared. Well, 3 times 2 is 6. n squared, multiplying variables same bases. Add the exponents. There you go. 3n squared, 3n. 3 times 3 is 9, and then n squared times n is n cubed. 3n squared times 4, 12n squared. So again, you got to find the greatest common factors of all the terms involved in the polynomial. Factor out each term. Start with the coefficients, just like you did in 4th, 5th grade. All right, and then just list out the variables you have, expand them out. All right, and then find what they all have in common and pull those out, divide them out. Okay, we'll do some more of these practice in class. But here's one that I'd love for you to try right now. We could take a look at this when we get back in class. Here's one to try on your own, and then we'll do some more of these, like I said, as we get back in the class. All right, see you guys then. Hopefully you learned something new.